Hey guys, it's Mary. Welcome back to Study Journey. Welcome back to the Python series. This is episode 6 of the Recursion Problem Set series, and in this episode we're going to be looking at part 3 of Caesar Cipher, and that is going to be ciphertext message. So without further ado, let's get into the video. So in the previous episode, we finished doing the plain text message, and now in this episode, we're going to be working on ciphertext message. So given an encrypted message, if you know the shift used to encode the message, then decoding it is also essential. So message is encrypted message, and then S is the shift used to encrypt the message. Then we have to apply the shift that gives you the original plaintext message. So it says to fill in the method of the ciphertext message according to the specifications in the doc strings. And that is right here. So first, let's delete this. And as always, I change everything to indentions so they're all uniform. And so first we have to initialize a ciphertext message object, and then the text is just the message's text, and then a ciphertext message object has two attributes. The first one is self.message_text, and this is a string determined by the input text. And then self.validWords is a list, and it is determined using helper function load words. So first what we have to do is initiate it. So just like what we did prior to this in plain text message right here, we have to initiate it by using super.initiate, and then it takes in the text because we're initiating a ciphertext message object. And then so next it says that the decrypt message it decrypts the message text by trying every possible shift value and trying to find the best one. And it says we will define best as a shift that creates the maximum number of real words when we use apply shift on the message text. So if S is the original shift value used to encrypt the message, then we should expect 26 minus S to be our best shift value for decrypting it. So here's a little note that if multiple shifts are equally good, that they all create the same number of maximum words, then you can choose any of those. And then their corresponding decrypted message to return. So what we should return is a tuple of the best shift value used to decrypt the message and the decrypted message text using that shift value. So I'm going to indent everything as always. And then the first thing we had to do is set what the best shift is. And so for right now, we don't know what the best shift is, so let's start at 0. And then so the maximum valid words that we receive right now is also going to be 0, and we're going to be updating those later as they expand. So what is our decrypted message? Well, we don't know what that is, so I'm going to set it to an empty list for the beginning, and then we're going to update it as we go. So how we're going to find this is for every shift in range of 26, because it goes from 0 to 26, then the decrypted text should be self.apply shift, and then it is going to be 26 minus the shift number because we're trying to decrypt it. And then the same for valid words count. And then for valid words count, we're going to be letting this be the sum of the words in self.valid words for word in the decrypted text split. So dot split. And what we can do right here is we're actually going to see if the valid word count is greater than the maximum valid words. So if valid words count is greater than the maximum valid words that we set, which is 0 right here to begin with, then we're going to update the maximum valid words count to equal the valid words count. So this updates the maximum valid words, and then the best shift is going to be 26 minus the shift. And then the decrypted message is just going to be the decrypted text. And make sure to indent these because these are inside the if. And then finally, we're going to return the best shift and also the decrypted message. So now that we have this, we can save it and actually test our code. So we can actually write 2 test cases for testing plain text message, and then 2 test cases for ciphertext message used to display the input and then the expected output. So right here is a to-do to write the test cases. So it has already given us right here the plain text is hello, and then the expected output is this. And then so here we're going to actually get the actual output by calling our function and seeing if it works. And then so let's do an example one for ciphertext message. So if the ciphertext is equal to ciphertext message and the word was what we got from the output of the encryption of hello, which is JGNNQ. Then let's print out the expected output, which should be the opposite of it, which is hello. So expected output, and then it should be shift by 24, and then the string hello. Then now let's print out the actual output. And that is when we call the ciphertext.decrypt message. So now that we have this, let's Command S and then save our code right here. And then let's open our terminal. So we know that first we go into CS practice, so cd CS practice. And then from there, we're going to open PS4. So cd PS4. And then now that we're in here, we're going to be testing the ps4b.py. So Python 3 ps4b.py. And then as we can see, for right here, it says that it was never closed on line 110. So let's go to line 110 and close it. And then Command S to save, and then run it again. And as we can see right here, the actual output matches the expected output right here. And then for the actual output and expected output, it is also the same. So we can write more test cases for each one, but this is essentially what we did. So we wrote the code that will get us the output that we hope to get after shifting it by 2 right here, and then decrypting this message, which was the word hello, and we shifted it 24, which is also 26 minus 2 if we can see that these two are actually corresponding to each other. And then so the expected text that we printed out is equal to when we called the function, this is what the actual output is. And as we can see, it matches each other. So they are the same, So we can see that our function for the get message text encrypted works, and then also it is the expected output and actual outputs are the same for the decryption of the message. So now that we have this, we have just finished this whole part B of Cipher Like Caesar. And so in the next episode, we're going to be moving on after we finish all 3 of these, as we can see, and we finish testing. We can do substitution cipher in the next episode.